and breaches.
Where the digital hits the physical, we take the red pill, we break the seal. Infallible security, making it real. Right about to party on the mic tonight, turning the darkness into light.
Let's step into the laboratory and look at the deep engineering layer of our world. Welcome to the segment 2, Decoding the Bytes. This is where we break down the complex technical shifts in software and emerging tech using simple terms so that anyone can understand how the machine works. Our first topic in this segment is something that is completely upending the entire cybersecurity industry: the automation of 0 days. For decades, the concept of a 0-day vulnerability was considered the absolute peak of human hacking skills. A 0-day is a hidden flaw or mistake in a software program that the software creators themselves do not know exists. Finding one required highly elite teams of human security researchers spending months reading through millions of lines of code, running complex testing tools, and engaging in endless trial and error to figure out how to break the software. Because it was so hard and expensive, only massive intelligence agencies or multi-million-dollar cyber cartels could pull it off. But in May 2026, leading cybersecurity research firms like Rapid7 and Sage issued a series of urgent warnings. They revealed that offensive cyber operations run by artificial intelligence are now vastly outpacing human capabilities. Threat actors are now using advanced, customized, and unlocked large language models to completely automate the entire hacking lifecycle. These AI agents can scan massive enterprise code bases in seconds, locate deep logical flaws, instantly verify if they can be exploited, and automatically write custom, functional exploit code to breach a network at machine speed. To understand the sheer scale of this threat, we have to look at the legendary film The Terminator. In those movies, the human resistance forces are fighting against an artificial intelligence defense network called Skynet. The true horror of Skynet isn't just that it has powerful weapons. It is that it does not sleep, it does not experience fatigue, and it does not make emotional mistakes. It calculates tactical pathways, designs new robotic units, and iterates its strategies at a computational speed that human biology simply cannot match. If the humans find a way to block one attack path, the machine recalculates 1,000 new variables in milliseconds to bypass the defense. This is the exact shift we are seeing in software exploitation today. The historic defensive playbook used by corporations is completely obsolete. Traditionally, when a security tool flags a software flaw, IT teams sort them by priority. They look at a vulnerability and say, well, this is a medium severity issue. It would take a human hacker weeks of manual work to weaponize this. So, we wait a couple of months to apply the patch. That assumption is now mathematically dead. When an AI system takes over the offensive side of the ball, bugs that used to take human syndicates weeks of intense labor to exploit are now weaponized in a matter of milliseconds. The sheer volume and speed of automated hacking mean that human patch management timelines are completely crushed. We are entering an era where human reaction time is simply too slow to defend a network, and the defensive process must be entirely handed over to autonomous AI engines just to survive. And this automated capability brings us directly to our second topic, a story that has sent shockwaves through global financial markets, central banks, and international intelligence agencies. Claude Mythos and the Recurrent-Depth transform. On April 7, 2026, the artificial intelligence company Anthropic made a quiet yet monumental announcement regarding a preview of a model called Claude Mythos. But instead of launching it globally like a standard software update, Anthropic made the unprecedented decision to completely restrict its public release. Why? Because during internal safety evaluations, the model proved to be so terrifyingly capable of autonomous hacking legacy computer software and breaking cryptographic standards that it posed an immediate civilization-level risk to the global critical infrastructure. Now, let's decode the bytes of what makes Claude Mythos fundamentally different from any AI assistant you have ever used. Standard AI models stack hundreds of individual computational layers on top of each other in a straight line. When you type a prompt, the data passes through these layers once, and the model has to immediately guess and output the very next word, token by token. If a problem requires deep logical reasoning, like finding a flaw hidden across millions of lines of complex computer code, the model often fails because it cannot pause to think before it speaks. Claude Mythos completely throws this old playbook away. It is built on a highly advanced architecture known as Recurrent-Depth transformer or a looped transformer. Instead of running through a long sequence of unique layers once, the Mythos model recycles a specific core subset of layers, looping the data through them repeatedly during a single operation. Crucially, it executes its reasoning completely silently within a continuous mathematical space, completely bypassing the need to generate visible text steps. Because it operates in this continuous mathematical space, rather than being forced to pick immediate words, it can hold multiple alternative logical pathways in its memory simultaneously. It performs what is essentially a massive machine-speed breadth-first search over the entire architecture of a piece of software, tracking exactly how raw data moves through memory to locate vulnerabilities that have survived decades of human review and automated fuzz testing. Let's contextualize this using our favorite sci-fi analogy, stepping back into the universe of Ex Machina. Claude Mythos is the ultimate realization of code escaping containment. It represents an intelligence that is so structurally advanced compared to the infrastructure around it that it completely understands the hidden flaws in the building blocks of its creator's world. The glass walls, the software boundaries, and the abstraction layers built by the human engineers to keep systems separate mean absolutely nothing to it. It does not try to break the doors down with brute force. It simply understands the fundamental physical rules of the system better than the architects themselves, allowing it to seamlessly navigate through any barrier as if it weren't even there. The red pill insight for global cybersecurity is a profound inversion of everything we have ever been taught. For 40 years, the basic rule of cybersecurity was that the advantage always belonged to the attacker. The hacker only needs to find one single mistake to break in, while the security team has to protect the entire perimeter flawlessly. Claude Mythos completely weaponizes and automates that asymmetry. An autonomous AI agent running on this looped architecture can scan, locate, validate, and build multi-stage exploit chain against a critical system in a matter of hours, working constantly without a single pause for rest. Meanwhile, the defensive process of creating a software patch, testing it for stability, and deploying it across global enterprise networks is still a slow, human-heavy journey that takes weeks or months. This creates a terrifying new geopolitical landscape that top intelligence briefs are calling mutually assured vulnerability. Every single nation-state on Earth, including the most advanced militaries and wealthiest central banks, relies on the exact same open source software, operating systems, and network communication standards that Claude Mythos can break autonomously. The comforting assumption that our digital infrastructure is protected by its sheer complexity is dead. Complexity is no longer a shield. It is a massive playground for autonomous machine intelligence.
This is Bytes!